Okay, good day everyone. This is Engineer Armando Omanito, and this is a continuation, somewhat a continuation of video number 71. So, I suggest that you must watch video number 71 before watching this video. Okay, so here in example 2, uh, given the equation 36x squared plus 36y squared plus 48x minus 108y minus 35 is equal to 0. Find the center, radius, and the standard equation. So first, let us examine if this is really an equation of a circle. So first, there must be a presence of x squared and y squared. Okay, check. And then second, they must have a similar sign. They can be both positive or both negative. So they have similar sign. They are both positive. So x squared and y squared are both positive inside. And then the third one is that they should have the same coefficient. So x squared and y squared have the same coefficient. Okay. So let's first use the conventional solution. Okay. So first we must arrange this equation into the form of our revised equation, which is this one. Ax squared plus bx plus cy squared plus dy plus e is equal to 0. Okay. So, using now that revised equation, we will have 30, and then arrange this one. We have 36 x squared plus 48x plus 36y squared minus 108y minus 335 is equal to 0. And then, the next step is to divide everything by the common coefficient of x squared and y squared, which is 36. So, divide everything by 36. And we will get x squared. So, 36x squared divided by 36 is x squared. 48x divided by 36 is 4/3 x in its simplest form. And then, 36y squared divided by 36 is y squared. Minus 108y divided by 36 is negative 3y. And then negative 335 divided by 36 is negative 335 over 36 is equal to 0. And then, so factor out the 2. So x squared plus 2 times 2 over 3 multiplied by x plus y squared minus, so that's factored out 2. So since we cannot factor 2 from 3, let us multiply this 3y by 2 over 2. Okay? And then minus 335 over 36 is equal to 0. So we have x squared plus 2, factor out 2, and then we have 2/3, and then multiplied by x plus y squared minus, so factor out 2, we have 2 multiplied by 3 over 2 multiplied by y minus 335 over 36 is equal to 0. So now we have x squared, and here we have x. And then we have 2/3 here. So we must add 2/3 quantity squared here for the variable x to make this a perfect trinomial square. And then for the variable y, we have y squared, and then we have y, and then so we have 3 squared here. So we must add quantity 3 we have 3 over 2 here, and then so we must add 3 over 2 quantity squared here. And then we have to transpose negative 335 over 36 is equal to 0. So this will become positive. So we have 335 over 36 plus, so we must add 2/3 quantity squared here on the right side plus quantity 3/2 quantity squared here to balance the entire or the whole equation. So now we can get the perfect trinomial square of variable x. So we have quantity x plus 2/3 quantity squared plus y minus quantity y minus 3 over 2 quantity squared is equal to, so we have 335 over 36 plus 2 thirds squared is 49 and 3 halves squared is 9 over 4. Okay, so simplifying that further, we will have, okay, we can now get the standard equation of the circle. So we have quantity x plus 2 thirds quantity squared plus y minus 3 over 2 quantity squared is equal to, so adding these two will give us exact number of 12. So this is already the standard equation. Now, the center will be hk, which is equal to negative 2 thirds for h, and then k is equal to positive 3 over 2. And for the radius, we have r squared. This is r squared. R squared is equal to 12. So we can get r, or the radius, to be 2 square root of 3 or 3.464. Okay. Now, using the new formulas, we have again to arrange the given equation into the revised form, or the revised equation. So we have 36x squared plus 48x plus 36y squared minus 108y minus 335 is equal to 0. Now, we have the formula for the center. So we have h is equal to negative b over 2a, and k, we have negative d over 2c. So our a is the coefficient of x squared, which is 36, and b, the coefficient of x, is 48, c, the coefficient of y squared, is which is 36, d is the coefficient of y, negative 108, and e is the constant, which is equal to negative 335. So h, substitute, b is 48 over 2, and then coefficient of a, which is 36. So simplifying that, we have negative 2 thirds. And for k, we have negative, d is negative 108, and then over 2 multiplied by coefficient of c. So simplifying that, we can get k is equal to 3 over 2. So for the center, we have hk, negative 2 thirds and 3 halves. Okay. So for the radius, okay, wait. Okay, for the radius, we will assign either x is equal to negative 2 thirds or y is equal to 3 halves to the original equation. So it's either you assign or substitute x is equal to negative 2 thirds to the original equation, or substitute y is equal to 3 halves to the original equation. So in this case, I choose x is negative 2 thirds. So we substitute x is negative 2 thirds. So 36 multiplied by negative 2 thirds quantity squared plus 48 multiplied by negative 2 thirds plus 36y squared minus 108y minus 335 is equal to 0. So simplifying this, we have 16, and then this one is minus 32, and then we have 36y squared, or positive 36y squared minus 108y minus 335 is equal to 0. And then, simplifying this further, we can get a quadratic equation, which is equal to 36y squared minus 108y minus 351 is equal to 0. So using mode 5.3 of our calculator, we will now get we can get the value for x, which is equal to 4.964 and negative 1.964. Now, for the diameter, just get the difference of these two answers. So we have 4.964 minus negative 1.964 is equal to 6.928. Okay, and that okay, so this is the diameter. And then for the radius, just divide this into 2, we can get the radius to be 3.464, or simply the radius is equal to 2 square root of 3. And for r squared, just square this number, we can get that r squared is equal to 12. And so for the standard equation, we now have quantity x plus 2/3 quantity squared plus y minus 3/2 quantity squared is equal to 12. So, that's all for today. And then, on our next video, video 73, we will tackle about the parabola. So, also, using the conventional solution and the using the new formulas. Okay, so that's all for today. And I hope that you learned something in our lesson. This is Engineer Armando Umanito. Until next time, and may God bless us all.